Hey families, I have to confess with this video, I've really been struggling to figure out what I want to say. So I'm gonna say from the outset, I really like your feedback, good, bad, or ambivalent. I really want to know how you approach what I have to say. So please, please, please flood me with comments. I need data, and you are the people to provide it. So I'm going to try to convince you that the way I approach biology and teach it is better than all the other biology courses you could take. And I'm going to do that by telling two stories. The first was what convinced me, and the second was what didn't convince my daughter's teachers, but hopefully will convince you. So again, I really am eager for your feedback. So the first story is I was listening to, I think, one of the greatest educators of all time, and certainly one of the greatest living educators, Lisa Van Dam, and she was talking about, rather despairingly, about her education. She mentioned that, learning biology left really no impression on her. It started with a picture of the cell. And at this point, I was like, wait, is that wrong? I kind of assumed that the only way to start teaching biology is by starting with the smallest element of biology. But I reflected on what she said, and I realized that I had done a lot of self-teaching because I've always loved biology, and I've also had a lot of education. I have a PhD in molecular biology, and yet a lot of that training really didn't make me good at experimental science or even at solving my own problems. And that's a frustrating thing to admit given the decades of training I have had. Now, I think eventually I did figure out how to be good at those things. But if I can kind of make that process more efficient, teaching people how to be good at experimental science and even solving their own problems, I think that's really valuable. And it doesn't happen by giving people knowledge as if it kind of came out of nowhere. That's not how it's discovered, and I don't think that's how it should be taught. I think it should be a process of discovery, very much like how it was originally discovered. And frankly, I think that a lot of these historical scientists are amazing. They're heroes to me, and I hope that they'll be heroes to you. So when I realized that I had to radically alter the way I approached, um, teaching and learning with my daughter, I really had to hustle. And I've tried a lot of different things to kind of help her discover stuff. And it's amazing the ways in which I failed. When she was 4, I was trying to show her how you keep one variable constant and alter another variable and see what happens. And she really didn't understand what I was doing at that age. Any sort of pedagogical expert would probably laugh and be like, no, of course not at 4. But it was a surprise to me that, she just thought I was mixing stuff together. She didn't realize that I was trying to turn one knob at a time to see how that knob would affect the whole system. So I've definitely fallen flat in my face many a time. So there was one thing that I think I did really well, and that was when I asked my daughter and her friends, how do you move water with sticks? And I didn't answer them right. They kind of made some guesses, and I was like, I'm not going to tell you yet. And then a couple weeks later, I took them on a picnic, and we went to the local creek. And I had a backpack full of stuff. They assumed it was food, and I was like, okay, let's have our picnic. And they're like, with what food? I was like, well, through most of human history, the food you had was kind of what you see around you. So what would you do? And they're like, well, you could maybe build a tool and hunt. I was like, yeah, but the animals probably won't be there the next day if you're hunting them. Well, plants don't really go anywhere. You could probably plant crops. It's like, yeah, but that's that's going to involve some effort. Plants don't live off of nothing. What do they need? And they're like, water. I was like, true. How would you get the water to them? They're like, well, we could carry it in buckets. I was like, well, for most of human history, we didn't have plastics or buckets. So what could you do? And they kind of got stumped at this point. I was like, okay, you're in the bathtub and you put water in your hand. Does the water drip out of the back of your hand? And they're like, no. And they're like, oh, we could use skin, like animal skin, to make like a bag to carry water. I'm like, yeah, you sure could. And that's what people did. I will say that if you want to water your crops, you're probably going to be carrying 10 pounds of water roughly 1,000 times a day. Crops need a lot of water, and water is really heavy. So what could you do to make that easier? And they're like, well, and that's like, so throughout this process, I'm just giving them hints and they're figuring out for themselves how to move water with sticks. That is to make an ancient Egyptian shadoof, right? So you've got a skin bag at the end, like hanging from a stick. That's sort of a lever that you can prop up on like the crook of a branch in a tree, so that like you can lever the water, which is a simple machine that just makes your job so much easier. And they had a blast just playing with the shadoof, and they really remembered that. That left quite an impression on them. And my daughter was 6 when she did this, and she's still really proud of it. So I'm telling you the second story to say that I brought this up to her teachers, and they were, and the idea was that I wanted them to try to approach teaching the way I was trying to approach teaching. That is to kind of have kids figure out how these discoveries were made, kind of rediscover them for themselves, because it just seemed to leave such a stronger impression, and they seemed really, really proud of themselves for figuring this out on their own. And when I told that story to my daughter's teachers, they were like, that's nice. And that's when I realized I didn't really know how to convince people of what I was so convinced of, that doing an inductive approach to biology, where you start with observation and you look for correlations and you see which correlations may have a causal relationship. A lot of people seem pretty agnostic to that approach. So to this day, I'm still kind of flummoxed as to what I'm not saying or maybe not understanding that makes me so convinced that this is so much better, and most people kind of indifferent to. I will say that I think going forward, it's going to be so valuable for my daughter to have built and discovered all the things we've built and discovered together. I genuinely envy the person who gets to read her college application or a cover letter to a job application, because she'll be able to say, when I was 6, I built a shadoof. When I was 7, I built an Archimedes screw. When I was 8, I built a robot. When I was 9, I built a Galileo incline to show how part of the reason why the moon doesn't crash to the earth. I mean, I truly do envy anyone who gets to meet her for the first time in that way and just learn what an extraordinary child she is. So like I said, I really appreciate your feedback. Also, as always, please subscribe, like, and share this video with people you know who have kids or know kids or maybe have seen kids at some point. Yeah, and if you'd like, I have a PayPal account where you can tip your narrator, your biology tutor, because I'm trying to make this my side hustle. So thank you as always, and I'll see you next time.